Okay, for this one, aluminium oxide is the mineral from which aluminium is extracted. What mass of aluminium would be extracted from 4,800 kilograms of aluminium oxide? Give your answer in kilograms. The thing about this is you need to remember that when we work in moles, we're always working with grams and not kilograms. So for this, we need to do a conversion to grams. You will frequently encounter this in the higher paper, so you need to make sure you remember that conversion, because otherwise you're going to lose one of the marks. It's also slightly more complicated ratios. So we have a 2 to 4 ratio here. So it's it's aluminium oxide making aluminium. So we're looking at a 2 to 4, which is basically a 1 to 2 ratio. So that's what we'll work with after we've simplified it. Now, the number of moles here, mass over MR. Keep writing the equation down to keep yourself right. So we have 4,080 kilograms of aluminium oxide. That is for three zeros in the end. That's the number of grams that we have. Now we need to now convert this into the number of moles. So the MR is 102. Okay, so that is 40,000 moles. Okay, so we need to then basically times that by 2 because of the 1 to 2 ratio that we're talking about here. So if we look at our mass, the mass is the number of moles times the MR. So the mass here will be 80,000, because times the AR for aluminium, which is 27. Which is 2160000 grams. Now they were looking for the answer to be in kilograms here, so we'll put that into kilograms. So it will be 2,160 kilograms, and that would be your final answer. Okay, so look at this one then. How much ammonia would be produced from 1,500 kilograms of hydrogen when it's used in the manufacturing process? Here's our ammonia. Slight problem with that is 2NH3. So that's the correct way to write it. So how much ammonia would be used if 1,500 kilograms of hydrogen is used in the manufacturing process? So this is a 3 to 2 ratio. So let's look at the number of moles of hydrogen we have. So we have our 1,500, but we change this to grams by multiplying by 1,000, and that's divided by 2. So that's our 750,000 moles. Now it's a, like we said, it's a 3 to 2 ratio, so all we've got to do here is divide this by 3 but times it by 2. So that will help us to work out the number of moles of ammonia that we're going to get. So if I times that by 2 and then divide by 3, so it's 500,000 moles. looking at the other side of the equation, the mass is the number of moles times the MR. So the mass will be our 500,000 moles times the MR of ammonia here, which is 17. So times 17, it's 85 million. That would be grams, but then the answer needs to be in kilograms to be sensible here. So that's 8,500. If we just cancel off those zeros, that's 8,500 kilograms, or 8.5 metric tons. It's a lot of ammonia. Okay. Yeah. So again, industrial style questions here where we're working with very large quantities of materials. So in a blast furnace, iron oxide is reduced using carbon monoxide. What mass of carbon monoxide is required to produce 2,240 grams of iron? So here's our iron and here's our carbon monoxide. So the number of moles is the mass over the MR. So we have 2240 kilograms of iron, but we need to change that to grams, divided by 56. So the number of moles will be 40,000 moles. Now this is a challenging question because what you need to be aware of here is the way around that they have the way around that this has been asked. So we're looking at this side of the equation here. So we have the iron and we're working backwards effectively here to work out the amount of carbon monoxide that we needed. So we know the number of moles of iron. So it's 2 moles of iron makes, so it's a 3:2 ratio, but we're obviously working backwards here. So we take our 40,000 and divide by 2, and then times it by 3. That will give us the number of moles of carbon monoxide that we needed. So divided by 2 times by 3 gives us 60,000. Of carbon monoxide. So mass will be the number of moles times the MR. That's 60,000 times the MR of carbon monoxide, which is 28. So it's 168 grams, but again, it makes sense to change this into kilograms, so it's 1,680 kilograms would be your answer for that one. And then the last one, how much aluminium hydroxide will be produced when 80 grams of sodium hydroxide reacts with aluminium sulfate? So here is our aluminium hydroxide, and when 180 grams of sodium hydroxide, so here's our sodium hydroxide, so it's a 6:2 ratio here. Okay, so working out our sodium hydroxide, number of moles is the mass over the MR. Number of moles is 180 divided by the 40 sorry, not yes, the 40 of the sodium hydroxide. So the number of moles will be 4.5. Now the mole ratio here is 6:2. So if we take our 4.5 moles here, if we divide it by 6 and times it by 2, we get 1.5, and that will be for the aluminium oxide. Okay, so the mass here is the number of moles times the MR. So it's 1.5 times the MR here, which is 78. So 117 grams. Okay, so that was higher challenge, more awkward ratios, and working with kilograms for industrial style quantities rather than school laboratory style quantities. So if you can do all of them, then you've got it. Looking at theoretical yield next then.